We're solving problem 18 from the 2024 F equals MA exam. A satellite is initially in a circular orbit of radius r around a planet of mass m. It fires its rockets to instantaneously increase its speed by delta v, keeping the direction of its velocity the same so that it enters an elliptical orbit whose maximum distance from the planet is 2r. What is the value of d? Hint, when the satellite is in an elliptical orbit with semi-major axis A, its total energy per unit mass is negative gm over 2a. So we know that our velocity initial from our formula tells us that this is gm over r. And, well, what is a in this case? Well, since you're increasing the circle by 2r, well, this is just r plus 2r, since you're increasing it, and then dividing it by 2, which is 3r over 2. Now, it tells us that when we're here, the semi-major axis is A, so we have this. Total energy per unit mass is negative gm over 2a. Since we have this value of a up here, we can substitute it down on this denominator to get that, well, 2a times 3r over 2 is 3r. Or just 2 times 3r over 2, because you're substituting in the a. So we have this form now, and our total energy output is E equals our kinetic energy 1/2 mv p squared, because that's after it, and then subtract gm over 3r. Now, since you want to solve for v of p, well, v of p squared, well, you multiply this 2 across and get this m over here. So this is 2, I should do 2 gm over 3r. Or yeah, no, since you're dividing, it's out. So we have this form now, and you want to square root it, so v of p simply is the square root of 2gm over 3r. Now we want to find the total change in our velocity, so delta v is simply the velocity after it minus the initial one. So this is 2gm over 3r. Take the square root of that and then subtract the square root of gm over r. Now what we can do here is, well, this can factor out to square root of 2/3 minus the square root of 1 in this case, because that's the coefficient when you factor all it out. This is just 1, and then you multiply it by that constant square root gm over r. Now, since we can estimate that, well, the square root of 2/3 is like 0.81, this part has got to be about 0.18 or so. So this is just 0.18 gm over r. And this isn't really accurate, but we can tell that the answer choices, it's got to be close to the answer choices. The closest answer choice is B, which is 0.15 times the square root of gm over r. That's our answer.